Alright, now on to a slightly more difficult problem here, where we have my son is now pushing the same car with a greater force of 15 newtons. The coefficient of friction between the car and the floor is the same as what we just solved for in the previous problem, which is 2.00. What is the acceleration of the car being pushed? So, again, I'm going to draw a free body diagram here first, the forces acting on the car that I know. So again, you know, if it's on Earth, I know the weight's pulling down on it. My son is pushing on the car to the right. And there's a normal force pushing up from the floor. And then we have the frictional force going against the push. Okay? So, now I'm going to pull out, well, first let me write down what I'm trying to solve for here, and that's my acceleration. That's my unknown. And let me write down my knowns. Again, I know the mass, it's the same car as 0.5 kilograms. And the force, applied force that he's pushing with, is now 15 newtons instead of 10. And the mu, the coefficient of friction, is 2.00. That's actually all I know. So, to solve for the acceleration, you have the same motion equation you had for before that dealt with acceleration, but we don't have any velocities or times or even distance in this problem. So the only equation that we really have that deals with acceleration is Newton's second law. The sum of the forces is equal to ma. All right. So the sum of the forces, since the acceleration is going horizontally, presumably to the right, I'm going to look at the forces that are also going horizontally. Okay. Now, if it's accelerating to the right, he's pushing it to the right, so I'm going to assume that it's going to the right. That means that the applied force is going to be greater than the frictional force. So to show that it's greater, and since they're going in opposite directions, I'm going to write it as the applied force minus the frictional force is equal to mass times acceleration. Okay? And the 15 newtons, that's my applied force, but I don't know my frictional force. So, what to do to solve for the frictional force? Again, I don't have a whole lot of options for frictional force here. I just have the 1, and that's mu times the normal force. And so, to solve for the frictional force, mu is 2.00 times the normal force. Now, vertically again, the acceleration is 0, so I'll just write it as a sub y is equal to 0. And so that means that the weight is equal to the normal force. And so the weight, I solved for in the previous problem, was 4.905 newtons. So I can plug that in for the weight or also the normal force since they're equal. So the normal force is my 4.905 newtons. So to solve for frictional force, just multiply two of those numbers together, and I get 9.81 newtons. So there's my frictional force. I now just plug it into my original equation, 9.81 newtons. And that's equal to mass, which I just solved to be 0.5 kilograms, times my unknown acceleration. So algebraically, just to solve for this, I'll just do a simple subtraction here. And that's just 10.19 newtons. And that's equal to 0.5 kilograms times acceleration. And so when you do the actual math, though this is a horizontal acceleration, that's going to come out to be 20.38 meters per second squared, and that's actually that's pretty large. Okay, so that's the end of the second example problem to solve for acceleration.